So what I'd like to do now is I'm going to go through some of the common mistakes that people made in assignment number 1. And this is always fun. This is a chance for you guys to ask questions about what went wrong. I won't necessarily give you the right answer, but I'll be happy to answer questions. And so I strongly recommend that you take a look at this stuff and try to see if you can figure out why I commented what I did. The first thing, I always have to make this point, don't delete the to-do statements. That's how I go through real quickly and figure out where you need to address the code. So if you remove the to-do statements, it takes me a lot longer to have to go find out what you did. So don't delete the to-do statements. So let's take a look at some of the common issues that people ran into. This is gaze into Palantir. And there was a bunch of mistakes people made. So people often would do rather complicated things to check to see whether or not the thread had been interrupted. It's actually really, really simple. So these are things that are incorrect, way too complicated. This is also too complicated. This is sort of wrong. That's checking whether something's running. That's not really the right way. It's checking whether a thread has been interrupted is very simple. So you have to do that. Then you'll also see here that this is not really a bug. It's just a comment. This code here goes ahead and tries to get the Palantir, and then it goes into a loop, and it tries to get it down here again. You can refactor this loop so that you only call the ... one time. You don't have to call this multiple times. So that's an easy thing to do. And also, it's also a good idea while you're in this loop to also check to see whether or not you've been interrupted, because we want to be as responsive as possible to interrupts. So it probably isn't a bad idea to put a check there as well. OK, so that's one common set of things I saw. So this was kind of a mistake. So you can see the person tried to get the Palantir up here. That's what I'm leaving out, so you can do it yourself, ... And then they went into a loop, and they said, well, Palantir equal null, pause, but that's all that they had. So that loop is unlikely to terminate anytime soon, because it's never going to have an opportunity for Palantir to be non-null. So that was a mistake. Let's see, what was this? Oh, this is a similar kind of problem, similar kind of thing, not really making the checks and so on that are necessary in order to ever get out of that loop. OK, for people, a lot of people did the grad student version. That's great. You don't have to, but it's not hard to do. And so here's a really subtle couple problems. So first of all, you don't need to use set along with an operation like add and get, or increment and get and increment, or increment and get, or so on. Those things have the side effect of updating the atomic integer. So you don't, this is overkill. You don't need to do both those things, right? Another thing is, rather than using add and get 1, just use increment and get. That's a little bit more concise. It's kind of like a plus operation. This is a more subtle problem. So a whole bunch of people did this. They would first check to see, let's see, they would first do something, and then they would check the value, right? So they would first increment, and then they would go ahead, and then they would check the value to see what it was. Can anybody tell me what's wrong with that approach? Why is that potentially a problem? To increment here, and then check to see what the value is. Right, but what would be the problems? You're absolutely right. Right, so the issue there is, as I think you were hinting at, between the point where you check, between the point where you increment and the point where you check, what might have happened is you might have incremented it, and it might have gone too high, and then another thread would come along and decrement it, and then it would appear to be like it was the right place. But that was only because sort of the accident at which things ran. So that's a real subtle issue, but that's the kind of things you get into all the time with concurrency and race conditions. So the thing to do is to both add, increment, get, and check the result, right? So that would be an atomic operation. OK, another problem down here. This example doesn't actually implement the spec. The spec says that it calls shut down if things go wrong, and that's not what this does. So make sure that you implement the spec properly. That was another common problem people had. Similar thing, this is a minor one, just use decrement and get rather than add and get -1. All right, now we're getting into lots of fun problems with begin being threads. A lot of problems in here. So let's see. Oh, yes. What's wrong with this code? We're creating the runnable one time, and then we're passing that runnable into all the threads. But of course, if you look at what the runnable is supposed to do, it's supposed to keep a separate set of variables and loops for each of the beings. And we're only making one of these things, so they're going to be shared. And God knows what that's going to do, but it's going to be really weird. Here's just a little side note. This isn't really a bug, but just learning to be a better Java programmer. You don't need to put the thread inside the open-close brackets, less than and greater than sign. The compiler can deduce that that's what you're doing. That's if you're using Java 7 or later. This might be right. It's just way too more complicated than you need it to be. You really don't want to be adding this thing like this. It's probably going to get you into trouble, but it's more complicated than you need to make it. So be careful with that. You don't have to make it nested like that. I would recommend allocating the thread and the runnable, sticking it into the list in one loop, and then calling start in a separate loop. By the way, this is, later we'll get to a better way to solve this whole problem, but what's kind of the downside with creating the thread and runnable and calling start all at the same time, and then looping around and doing the same thing for the next being, versus creating all the objects and then going ahead and calling each of them, calling them start on each of them in a separate loop? What's sort of the pros and cons of each approach? So the main problem with, yeah, go ahead.
Is it that you can't access like the threads afterwards because you don't name them?
As long as they're in a loop that you can loop through and say start, 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 you'll be okay. As long as you put them in the array list, you're okay there. Yeah.
If you do everything in a loop, it's more staggered between each thread.
Right. So what happens is if you create the runnable, create the thread, start it, that takes a little while. Now that one's off and running. Then you loop back around again, you create the thread, create the runnable, start it. Then that guy starts running. So by the time you get done creating them all, the first guy's probably done, right? So they're not really running all at the same time. Now we're going to come back later and talk about how barrier synchronizers can make this whole issue go away entirely. But as a general rule, it's probably better to finish creating them all and then go ahead and start them all because they're more likely to start running at the same time. Again, a barrier synchronizer, though, is the way to go for that. We'll talk about that later. Since it's not too hard to use lambda expressions, I gave everybody a recommendation to use lambda expressions rather than using runnables just because they're a little bit more concise. Your code isn't wrong if you do it this way. It just could be done more easily. A bunch of people did very complicated things here with all kinds of is alive and stuff like that. Way too complicated. Just use join. We'll talk more about join later. But just get used to it. Join is just a way of waiting for a thread to finish, and it's real clean and easy to do. This is too complicated. Here was kind of a fun one. What's wrong with this code? We say new thread, new runnable, blah, 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 run. Right, it's supposed to be start. So this will sort of actually work in some weird definition of work, but it actually won't create a new thread. And instead, it'll just basically block in the main thread. So it's completely missing the point of why we're doing this. And then a lot of people did this too. What's wrong with putting this here? Let's assume this is start for sake of argument, not run. Agreed, but why? What's the reason why? What'll happen if we do it this way? Yeah.
It executes like immediately after we create the start thread.
Right, and what will the consequence of that be?
It'll end the program.
Right, the program will start up and stop right away, and that's because this done call will tell the thing, oh, we're finished, and it'll shut down, and so you won't actually gaze at all, or at least not very much. So you want to make sure this goes in the right place so that you're done after all the threads have finished. Otherwise, your gazing will be very brief. here was a give the person credit for using streams. That's good. But in this case, what's going on here is too complicated for its own good. We don't need to do this. So just use a loop with a join, and you'll be perfectly well off for this assignment. So that was just overkill. We'll come back later and talk about streams. Don't worry about understanding what that code is doing at the moment. So here was another thing. This person's creating a subclass of thread and having a run method and looping, and it was just way complicated. So this thing can be turned into like 3 lines of code or something like that. Much cleaner, much shorter. Using Java Lambda expressions makes it real clean too. And then something else that everybody should get in the habit of doing when it makes sense. It doesn't always make sense to do this, but it's a good idea to get in the habit of using a for each loop or the for each method rather than having a loop counter and walking through from I equals 0, I less than size. Why is it generally a good idea to get in the habit of doing something else besides this? What's the reason for trying to avoid writing code like this, even if it's correct? Right. The minute you've got a loop counter, you end up doing something like, oh, for I equals 0, I less than or equal to m being threads dot size. Very common mistake. I've done it a million times. And then you're like, why does my program not work? So if you get in the habit of using a for each loop or the for each method, and we'll talk more about these things, but those are kind of basic ideas from regular Java and Java 8, that means your code has one less thing to go wrong. And also when someone looks at code that uses a for each loop, it's real easy to tell what's going on. They're just iterating through every element in a collection. OK, so any other questions about those things? Yes?
You said that in a while we should check if the thread has been interrupted.
Yeah, that's the part where we're like trying to get the Palantir. We're trying to basically call the acquire Palantir method, where it will not block. Our current implementation doesn't block, just to make it easy. And so rather than sitting there just spinning and not checking to see if we've been interrupted, we want to check to see if we've been interrupted. And if so, we bail out, because there's no sense in waiting at that point. Other questions? Yeah?
How do we know where to check the thread interrupted?
Great question. So the solution here, there's a method called interrupted on thread, and it's a static method. And the way it works is that because it's a static method, it magically knows, and I'll show you later how this works. It's using thread-specific data, thread local storage. But basically what it's doing is if you say thread.interrupted, it knows to check the current thread to see if the thread's been interrupted. So that's all you have to do. It's real simple. We'll cover that in more detail. Yeah?
Is it possible instead of using join to use a countdown latch? Because I saw that online, but I wasn't able to implement it.
Right. We'll cover countdown latch as an example of something called a barrier synchronizer, and we'll cover that. And yes, that's absolutely the right thing to do for later assignments once we've covered that. For now, just use join.
What's the difference between increment and get and increment? Is the return value different?
Yes. So are you guys familiar with this? So if I'm in C or C++ and I say, int I equal 10, and I say int j equal plus I, or int j equal I plus plus, right? Those have different semantics, or different behaviors. So this will increment I by 1 and return the pre-incremented value. This will take the value of I, return it, store it in j, and then increment I. So not surprisingly, get and increment is like this one, and increment and get is like that one. So it's like pre-increment versus post-increment. And because Java doesn't support operator overloading the way C++ does, we have to kind of write it out in a more verbose way. Other questions? Great questions. So nobody got it perfectly right, but that's OK, because the whole point of the exercise is for you guys to take a shot at it. I give you feedback, and then you fix it. So there's really no reason not to get it right, because we go over the stuff. And if you think about my comments and what we talked about and ask questions, you should be able to get it right. So that is what you'll need to do for this part. The next assignment's due Thursday. That's dealing with synchronizers, which we're going to start talking about right now. And always remember that we don't always cover all these things in gory detail but they're in the, usually, should be in the videos that are linked into the assignment, so you can learn about that stuff. Yeah?
So we turn part A in again, and then...
Okay.
Because part B includes all this stuff, we just should make mistakes again.
Exactly. So if you take a look at the skeletons for part 1B, you'll see that there's a whole new set of things, which is in the model layer, the Palantir manager. But then I also stubbed out, I left everything from 1A stubbed out as well, so that just go ahead and copy your solution, or, well, be careful how you copy it because there's one little thing that's different. But, you know, cut and paste your old solution into there, after addressing my comments, of course. Then you'll solve part 1B. I will then give you feedback when it's due later this week on 1B. And then, you know, so what we'll do by the time we're all done in 2 more weeks or whenever we're done, you will have done 1A, 1B, 1C. I will have given you comments on each of those things. You'll address all the comments. Then you'll submit the final version, and we'll grade the whole thing. Okay. So you'll get 1 grade for the assignment, but we're doing it in parts for a variety of reasons, because I wanted to sort of stagger it so we would have a chance to talk about the topics before you had to do something about it, or at least talk about part of them. And also, it keeps people up. You know, if I give someone an assignment with 3 parts that's due in a month, everybody starts the day before. If we break it up into 3 parts, then we get them done incrementally, and it's less painful.
But like, there's actual folders for 1A, 1B, 1C.
Yeah.
Like when we turn in the final.
When you're all done, we will grade your solution for 1C, and that'll have 1A and 1B in it. So there'll be 1 thing we'll grade at that point.
So we don't need to do like two separate commits for the reviews and then the next one.
Well, it's kind of working like this. So you did 1A, I gave you comments, so we're not going to grade 1A, address those comments, you know, then copy them carefully into your solution to 1B, fill in the rest of 1B. I will then review 1B, but I'll only review the parts that are the 1B parts. I'm assuming you've addressed the 1A parts. I'm not going to review them again. And then for 1C, same thing. There'll be some extra stuff. And then when we're all done, then we'll grade 1C, which will have 1A and 1B in it. So it's cumulative. I mean, if you think about it, what else are we going to do, right? You're going to get a grade on the whole thing ultimately, but we're doing them incrementally. OK. So let us now switch over